Okay, so today in class we looked at tangent and cotangent, and tonight we're going to start looking at secant and cosecant. So 4.7, we're looking at cosecant and secant graphs. So what we want to start with is we want to remember that cosecant of x is the same as 1 over sine of x, and secant of x is equal to 1 over cosine of x. So when we're doing our graphs, we need to remember that same table of values, but we need to think of it as reciprocals of those table of values. So if we start with trying to graph the parent graph of cosecant x. So some things that we can remember from our sine graph. The sine graph starts at 0, and then it goes up to 1, and it goes down to -1. It goes from 0 to 2 pi, and then we divided it into its halves or its fourths. So this is what we would do for a sine graph. Okay, for a cosecant, everything will match a sine graph in terms of the parent function. Okay, so then if we think back to that table of values that we had for a sine graph. We started at 0, then we went to pi over 2, then we went to pi, then we went to 3 pi over 2, and we ended at 2 pi. So when we did sine, of x, sine of 0 was 0. Sorry. Sine of 0 was 0. And so if we think about what the reciprocal of 0 is, so the reciprocal of 0 is undefined. So when we think about all of these graphs, we're thinking 1 over sine. That's how we're filling in this table, is 1 over sine. So sine of 0 is 0, so 1 over 0 would give us undefined. Pi over 2. Sine of pi over 2 is 1. So the reciprocal of 1 is 1. Sine of pi is 0, so the reciprocal of 0 is undefined. Sine of 3 pi over 2 was -1. 1 over -1 is -1. And then sine of 2 pi is 0, so the reciprocal of 0 would be undefined. So what I end up having in my graph is from 0 to 2 pi, which is still one period. So our period here is still going to have a parent graph of 2 pi. Our amplitude will still have an amplitude of 1 on the parent graph. But we're going to have asymptotes. So I'm going to have an asymptote at 0, an asymptote at pi, and an asymptote at 2 pi. So our cosecant, because we're dealing with reciprocals, will have an asymptote at every single one of the points where sine was 0. So when we go to plot pi over 2 comma 1 and 3 pi over 2 -1. You can plot those, but since we can't go through any of these lines, your graphs will actually look like this, where there'll be u's going to positive infinity and negative infinity, with your minimums and your maximums of those being these points. One of the things that's interesting about the cosecant is that if you were to draw the sine graph, so here would be my sine graph for this same function, obviously with more curves than what I'm doing here. You are essentially taking this u from 0 to pi and you're flipping it to go the other direction. Then from this pi to 2 pi, you're flipping it to go into the negative infinity direction. So your cosecant, or your reciprocal, is just taking between zeros, or between where it crosses your axis, and flipping it and turning the zeros into asymptotes. Okay, so this is what your cosecant will look like. Now your secant will have a very similar feel. The only difference will be where sine is equal to 0 is not the same where cosine is equal to 0. So when we're going to next look at y equals secant x. So again, just like in cosecant, our period is going to be 2 pi as the parent graph, just like cosine. Our amplitude is going to be 1, just like cosine. How we draw our key points, we do it the same way we do a cosine. So with cosine, 0 to 2 pi, in the middle is pi, in the middle is pi over 2, and in this middle is 3 pi over 2. And we go up 1, down 1. So how we set up the scales and the intervals is exactly the same whether we're talking about sine, cosine, secant, or cosecant. The parent graphs all have the same intervals to start with. And even how we find the transformations, it'll be the same as how we've done sine and cosine. So again, this one we want to think. So if we go to our table of values, can you see this one? Nope. Okay. So if we go to our table of values, and again we're thinking 1 over cosine x. So we can start again the same way with 0, then go to pi over 2, then pi, then 3 pi over 2, and then 2 pi. So what is cosine of 0? Well, cosine of 0 is 1. Reciprocal of 1 is 1. What is cosine of pi over 2? 0. The reciprocal of 0, undefined. Cosine of pi is -1, so 1 over -1 is -1. Cosine of 3 pi over 2 is 0, so 1 over 0 is undefined. Cosine of 2 pi is 1, so 1 over 1 is 1. So again, I'm going to draw my asymptotes. And at 0, I go 1. Pi, I go -1. And then at 2 pi, I'm back up at 1. So very similar to the cosecant graph, these are going to go in the opposite direction, so to negative infinity and infinity, to get your cosine graph. Now, if we were to continue on, so this is one interval 0 to 2 pi. If I wanted to continue on to say negative pi over 2, so continue this way to negative pi over 2, I'd have another asymptote, and I could continue drawing my graph towards that asymptote. So when you look at these two together, they're the same kind of graph, just the asymptotes are shifted a little bit. And that's because, and they're shifted pi over 2, which is 90 degrees, and that's because every 90 degrees, sine and cosine switch from 0 to 1, depending on where it is. So when you have these two graphs, you still start with the same 0 to 2 pi. You can make the same transformations. The only difference is where your asymptotes fall and how you would draw your curves, considering Cosine, you're going to have these two little halves, but if you wanted to, you could continue your parabola or your upside down cosine to make two full looking things like we did for sine. So in class tomorrow, let's see, actually I wanted to do one more here. So I want to do one more with you guys that is a cosecant, where we're going to do your basic cosecant like we did here, but we're going to make some transformations to it. So again, when you're doing your your secant and cosecant, you're constantly thinking the reciprocal value of whatever sine is. So if you were to plug in sine of that angle or sine of that value, what would be the reciprocal? Would it be undefined? Would it be 1? Would it be 2? Would it be whatever? So when we take this same idea of how we get the asymptotes, and what I want you to notice is where the asymptotes fall. So here our asymptotes are at the beginning, end, and middle. So when you're doing your cosecant graphs and you're using patterns like we did for sine and cosine, your asymptotes are going to be at the start of your period, the end of your period, and right in the middle. And then these 2 points here are going to be your top and bottom for your curves themselves. Now for secant, our asymptotes fell excuse me, at the 1/4 mark and the 3/4 mark. So if you think of how these are all broken into 1/4, 2/4, 3/4, 4/4, it's at the 1/4 and the 3/4 markings are where your asymptotes fall. So keeping those two facts in mind, when you go to do your 0 to 2 pi or whatever your interval is, your asymptotes should always fall at those markings within whatever your period is. So let's try one where we have a couple of shifts to work with. And then we're going to do at least one, if not two more graphs in class before you guys get started on your assignment. So the one I want to do with you right now is -3 cosecant x plus 2. So just like in our other graphs, I'm going to start with amplitude. So our amplitude here, same thing as before, it's the number in front. My period, so I don't have anything being multiplied to my x, so that means it's just going to stay 2 pi. For a vertical shift, I come over here, it goes up 2. And for horizontal shift, I don't have anything being added or subtracted there, so I don't have one. Now I do want to make a little note to myself that I have a negative. That means I'm going, instead of on the normal cosecant, how we started up at 1, we're going to start down instead of up, and that's because of that reflection. So I need to make sure I can go an amplitude of 3 with a vertical shift of up 2. So that means my highest point has to be 5, 2, so there can be my x-axis, and I need to be able from 2 to go 1, 2, 3 for my amplitude. Then on my period, I'm going 0 to 2 pi because I didn't have any horizontal shifts and I didn't have any period changes. So I can go ahead and do my basic 0 to 2 pi intervals. And then I can go ahead and start with some things about the graph. So because it's cosecant, that's sine, I'm going to have my asymptotes at the beginning, in the middle, and at the end. So using that pattern with cosecants, how our asymptotes will be at the beginning, middle, and end of our period, I can draw those right away. Now I know I have my vertical shift of up 2, so this is my new 0 that I go around. So for my amplitude here, instead of going up 3, because I have to start down, I'm going to go down 3, and there will be my first point, and I'm going to draw it away from my horizontal. At 3 pi over 2, I'm going to go up 3 from my horizontal, and I can draw going away from the horizontal. And that would be one period of your cosecant graph. So again, the key things you want to remember to graph a cosecant is where are the asymptotes, for this graph, and that is beginning, middle, and end. Other than that, you just want to remember that your graphs will always go away from the horizontal, wherever that is. So if in this case it was up 2, if it's the y-axis, wherever it is, your graph has to go away from it. So you want to go away from the horizontal. I'm just going to put that in quotes because we're talking about wherever that horizontal moved if there was a vertical shift. Okay, so these are really the only two differences that there is between a cosecant and your sine cosine, is that you have asymptotes to deal with, and you want to make sure your graph goes from your amplitude away from the horizontal. So like I was saying in class, we're going to do a secant graph, and maybe I'll have prepared one more cosecant as well in case you guys want to see another one. But if you have questions, please note them, and we can definitely go over it tomorrow.